Hello, hope everyone's IGDC is going well so far. Today we're going to talk about our game Frontier Paladin and the action system using GAS. My name is Oomerbhoy. This is Mohit Pilankar. I am the creative director of the game. Mohit is a senior game programmer. And yeah, take you away. So we've been working on this game for 2.5 years. It's built on Unreal Engine 4.27. And we've shipped a game before, so that really helped us when it came to deciding what engine to use and how to use it. I'll show you a little bit about the game first, and then Mohit will get into the details. Also, I'll mention our colleague Dhanesh, who is in here today, but really helped us with everything.
So the main issues we had while developing our last game, minus Middle, were like the code was fragmented all over the place. It wasn't in like its own module, and the problems it caused was that if we tried to fix one thing, it would break 5 other things, as you already know, any coders might know, which is very frustrating. And there was also limited designer flexibility, which means if anybody wanted to like modify the speed of a train or like the max number of compartments on a train, they'd need to modify the same blueprint. And that was a problem because it is an asset, and we were using Git for version control. And one change would override the other, and they would have to match each other's changes and get the final change in. There are also a few more requirements we had to make this system, and it was that we wanted a system that is modular and flexible, and so that we can add it as a plugin and then simply use it and not worry about other things, like it being referred to by many things. We also wanted to implement data-driven gameplay, so the data is not inside the blueprint itself or not inside code, but it is taken from somewhere else, an Excel sheet or like a curve table, and it is then reused in code, and it does its thing. We also had an issue where we could have made our own system. We could have reinvented the wheel, but we chose not to do that and use the gameplay ability system. So because we had already worked with it in our previous project, and we wanted to use the same system. It is battle tested. It is already tested by Epic with Fortnite and Paragon, and it works. We know it works. So that was a perfect fit for us. The focus on this talk is going to be how we have used the gameplay ability system and created our own system on top of it. I cannot like cover the basics of the gameplay ability system in depth in this talk because there's not much time to cover it. But you can find resources for it online on YouTube or the Epic's learning portal. I would like to cover some of the gameplay ability system, though. So it is dependent on you knowing these things before we head further into the action system. So an ability system component is the main component in for the gameplay ability system. It needs to be on all actors that are going to be participating in the abilities. So if any action has any attributes, health, stamina, or anything, those actors would need an ability system component on them. Then there are the gameplay abilities themselves, which are the actual logic and the functionality of like what you are doing. So if you are reducing the health, you are reducing it inside the gameplay ability. You might do that with help of different tasks, like ability tasks, which run asynchronously and do this thing through like gameplay code, and then change the attributes. But the actual changing of attributes is done by gameplay effects. The effects, you can apply the effects directly onto the target, or you could create a gameplay effect spec. A spec is like a specification that you create and keep around so that if you don't want to directly apply it to the target actor, to the enemy, any damage or anything, you can keep it around and apply it later on. It's discussed later while in the caching bit of the thing. And gameplay cues are basically objects which define which VFX would be applied. There are two types of, I think, gameplay cues. One is actor-based, which will, when you activate an ability and an effect is running, and there's a gameplay cue tag on it, a relevant actor will be spawned for that gameplay effect, and it would stick onto the actor himself. And then whatever effect is running, if you want a wispy or whatever thing, while your character is healing, it will be in the gameplay queue. Same with the sound effects and everything. So the action system is basically two parts. One is functionality and one is data. The functionality part of it handles, this is where all the logic and code goes in. And it defines how we like apply the actions to different targets or actors. The action plugin component is basically a system that is developed to like slot in the actions onto the actors. So if you had like a repertoire of spells and you wanted to define key, I cannot equip more than a certain like power of spells. So if like a weight class of 10 is defined for the spells, and I have chosen 2 actions with 5 weight each, I can slot them in. But then if a third action, like a weight 3 action wants to come in, it can't. So like the functionality part is separate, and the data, like what damage is going to be done, how it is going to be picked up, that is coming in separately. This is just a class diagram of how everything flows. I'll explain each of it in a bit. So the action component is basically the ability system component. It has all the goodness of it, and on top of it, it adds the concept of prioritization. So it has the concept of like queuing actions. So if one ability finishes and another is to start after it, you can do it through that. So the different parts of it are like the queuing bit, which means if I am doing like a combo action, like swoosh, 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 but I want to like limit it when the next swoosh should happen. So when I do the first swoosh, and I want to the player to give me a second input in a certain window. And within that window, if the second input comes in, we can queue it queue the next action to be played after this one finishes normally. So that is windowed queuing. Then there is replacement, which means if a new action is starting, it will cancel the previous action that is currently running. So if a character is attacking and another character attacks him first, he has to go into like a reaction phase. It will cancel the action and start a new action on the character. Another is type of it is blocking. So basically, we can block any type of action from starting up in the first place if an action is currently running. Then there's parallel execution. Usually, we are just running one action at a time. But there is provision to run two actions simultaneously if we need it. There is also a concept of can activate action override, which is a function we made to for each action to be able to define if it can be performed or not. So here's an example of the tester playing it, and you can see the debugging tools that are already there for debugging ability system can be used in to debug the action system. You can see the action starting in the top right. Different actions that are starting when the player moves, the movement action starts. When the player dodges, the dodge action starts. So the debugging tools that were already there for the gameplay ability systems are being used for the action system. So I'll go deeper into the action types. Base action is basically inherited from gameplay ability. It has containers for queuable, swappable, and parallel tags. These are gameplay tag containers, which are in the form of tags are in form like combat action .sword .light attack .a. Each dot is like a graph-like structure where it can have multiple things. And here, using those tags, we can define what can be queued. So if I wanted to all the combat actions to be queuable, I could just say combat action .sword, and it will queue. It will tell this ability that any action which is starting with combat action .sword, whether it is light attack A, B, C, D, it can be queued. Swappable is something which will interrupt the currently running ability, cancel it, and start a newer ability immediately. Parallel, as I mentioned, it can run two simultaneous tasks. So, for example, if the guy is running and he's swooshing his sword, both actions need to run concurrently. So that can be done using that. Base action also has the provision to give a custom cooldown class, where if a particular action has a specific cooldown, it can be passed in through this thing. Effect applicator action inherits from base action, and this is the first class that can be directly initialized. Base class was the base action was an abstract class; it cannot be instantiated. This has provisions for three maps, T-map variables, which hold the primary effects, post-success effect, and active state effects. Primary effects are effects that are the main effects of this action. So if this is a damage-related action, it will hold effects related that will damage the target actor. Post-success are basically if the damage was successful. There is a case that the damage may not have been successful because that guy has some buffs or something. But if it was successful, what effects to apply onto the participant itself who tried to do the damage. Then there are active state effects, which are constantly being applied on the actor while the ability or the action is active. This is the first action class that has support for caching. A bit on it later. value modifiers. These are basically whatever you configured in those primary effects, post effects, are being done through effect value modifiers. And this is a screenshot of the inside the gameplay ability on how you can configure it. You can notice here that there is a drop down, and this is because this is marked edit inline new and default to instantiated in the uObject class specifiers. And then the variables for those are marked instanced. And that would allow you to define uObjects in the as classes themselves in the editor itself and configure it there. Here there are examples of two value modifiers. First is the effect value modifier. What this will do is below at the bottom you might see this part. This is a curve table entry where what it does is it tells what kind of player it is and what action it is and what is being modified. So the stamina duration here corresponds to this suffix that was passed, and it will pick the value that was that is for this level that is mentioned here. There are 20 levels in a curve table, but it will pick the first one because this was level 1 as mentioned here. And it will directly use that value. The second one we have made is a value range-based effect modifier. This is specifying a value directly, a third value, but it doesn't take it. It is for a charged effect. So if there is a full charged effect, a sword is going, you're charging zzzz, and something like that. So what it would do is, for the time you're holding it, it is defined by, oh, sorry. Sorry. For the time you're holding it, it is defined by the actual curve defined here. And the curve can go like this. So it will be flatter, and then right at the end, after all the time has finished for it, it will pick up the final value. So based on that curve, we calculate what value to pick based on this final value. This is the full value, 30. And if the player holds it for the entire duration, that value will be picked. This is the example where the tester is damaging the enemy. You can notice how the player is using the combos in sequence. Then the tester will go in and modify the values in a curve table. Re-import it in the engine. And you can notice the health bar at top, it is doing more damage to the character this time around. That was it. Basically, this is the benefit of data-driven gameplay. Data is in a separate curve table, and whenever it is modified, it gives you instant feedback in the game. This is an example of the post-success effect. Whenever the player hits the skeleton and it is a successful hit, his mana is increasing. But if he wouldn't have been if the enemy wouldn't have been damaged, the mana would not have been increasing, because it would only apply it if it was successful. Animated action. This is inherits from the effect applicator action, and has an ability to play an animation. So if an ability is activated, it would play an animation with it. If it is a spell activity, the character is doing some action when the ability activates, it will play that animation with it. It can also, it listens to montage events in the animation, notify events in the montages, and does specific things on them. More on it later when I get onto targeting. And it also supports caching. This is when an ability activates, animation is being played. As soon as the ability activates, the character does the animation that is programmed on the action. Combat action base inherits from animated action, so it has animations and introduces the concepts of limbs. Limbs here are like which limb on the character is currently going to perform that action. And we could have defined different damages for different limbs, and they could do concurrent actions if we wanted. But we later on removed that ability, and we made sure, because the game doesn't need it, we made sure the ability system component is directly on the character, not on like limbs. And we do the damages through them. But whatever is configured on the limb is for like the combos. So if it is light attack A, B, C, D, and it is going through that, the damage that is configured on like each action will be taken into account. So it is the weapon damage plus the action damage, and that will be the total damage that is applied to the target actor. Combat action inherits from combat action base, and this is used for melee actions. Whatever damage is being done is done through this thing. What this does is it triggers a physics simulation when combat state.strike event. This is the thing that is configured in the animation montage. When it receives this notify, it evaluates the collision between the swooshes. So if the character is swinging the sword, the notify will start at this point and end at this point. And between these points, spheres are being cast. Sphere casts are being done. All the characters that have collided with the spheres are being taken into account, and then damage is applied on them. Our ranged action is inherited from combat action base because we need the damage bit from it. And this also has the concept of effect caching, which I'll explain in a bit. This is being used for like spell-based projectiles, AoE projectiles, whatever we are using. We are doing that through the ranged action. The targeting mechanism for it. So whenever you activate a spell or like a target ranged action, what you need to determine is how is the target being found out, who is going to be damaged or what is going to be damaged. If the guy is aiming, it is like a line of sight check. If the guy is doing an AoE, the AoE will move based on player input and go to a certain place, and based on that point, the final destination for the projectile will be chosen. So a gameplay ability target actor is created for this purposes of determining who the final enemies will be, on which the actions will be applied, like on which the effects will be applied. And after, whenever the ability activates, it creates this wait target task called action task wait target data. There's also a predefined wait target data that Unreal provides, which does a similar thing. It waits for a target to be received. And when the target is received, it applies the effects on the actors. So here you'll see it in action, where he throws a AoE ability. And then if anybody is standing inside the AoE, all of those will be picked up and damaged. Caching. So data effect manager is something we have created for this game, where this is the one thing, this is the thing that manages the data for the game. So whenever a ability is activated, what it does is it goes in and creates the U effect actor application data. So we are doing this so that if like the original actor who casts or like does the ability dies, and like the projectile is in air, when the projectile lands, the projectile should do the damage that it should have done normally. We don't want it to crash or do some weird behavior. So what we do is as soon as the character activates the ability, whether it be an enemy character or the player character, we cache all the data, keep it, calculate everything, like what final damage will be done. We also store the instigator details on it, which is a weak reference to the actor, the ID on the actor, the team ID for the actor, and any custom data as object that is passed to the actor. We store projectile data, different speed, lifetime range, and count onto this actor itself. So what you have to understand here is this is a single data actor for all the projectiles that are being spawned for the action. It could spawn, it could be used by one projectile and discarded, or it could be something that if something is spawning 5 projectiles and they are going around like a bullet hell game, the data for each projectile is still the same. The action that initiated it was still the same, so data for all of it is still the same. So it can be taken in by from this system and reused again and again until it is no longer finally needed. This is just a screenshot of the effect actor group. The T-map here in effect actor application data stores like various effect data. So the primary effect would be stored in a different like a effect data F name would be passed, and it would be stored in those things. Here you will, to the right, you will also see that I'm applying the effect differently for different things. If it is an effect to be applied on self, it is stored separately. If it is effect to be applied on neutral characters, so if like a AoE exploded somewhere and it was something to heal the friendly characters of a player, it will go and do the allied team check, and it will pass and apply these effects, whatever there are. Neutral for like characters which are neutral or not on the team of the player, or like the other, which have neutral relationship with the player's team. And hostile is the other team. The flexibility this gives us is we can have like different teams of enemies as well. And we have utilized it as such. So like Hellspawn could fight the undead or something like that, based on the team specified. Data is captured immediately on activation, and it is preserved throughout the life cycle of the action using the gameplay effect spec, which is stored inside the effect applicator action data. On hit, whatever effects are there are applied on the characters whenever the on hit function is called. On hit is called when like all the final targets are determined by the target actor. They are given to the ability, and the ability then applies the effects on the actors, and then it applies the post effects on self if any are configured. Data is usually cleared automatically. It doesn't need manual clearing. But if there's some case where like multiple projectiles are being spawned, then we turn off automatic clearing and only clear it when the last projectile is destroyed. I have an example of it here, where the character is firing 2 projectiles. If the first one hits, the data will still be there. And when the second projectile gets destroyed, that is when the final data will be removed and everything will be cleared from memory for that action.
All right, so that was the presentation. We hope it was informative and detailed enough to sort of help you if you're doing a similar sort of system. We're here for a little bit after the talk, so feel free to come up if you have any questions. Check out our demo. It's at the Indy 40 section today and tomorrow, and thank you.